lot of people have had a lot to say about drivers lately. The Nvidia driver issues. Nvidia is known for their drivers, is known for producing stable drivers, certainly produces a lot of them, which actually might be part of the issue. But lately, everything seems to have gone tits up. I mean, what's going on with Nvidia? I mean, how come these drivers suck? And one thing I keep hearing about, complaints about, is the dual monitor issue. How we're seeing crashes with dual monitors, which happens with dual monitors with different refresh rates. Well, I have a 240 hertz here, and I have a 75 hertz. So I have a setup here that allows me to test things, and we're going to see if we can replicate these crashes, these problems, and then we're going to see if we can find a fix for them. But before we do that, on this channel, I want you to know that we boil things down. Okay? We make things simple. And sometimes I'll explain things in a simple way that would be far too reductive for people in certain industries. I'm not saying that these are be-all and end-all explanations that I'm offering. But I think that understanding things simply is the best way to understand them, and I don't think that you can get into the weeds about something before you understand it simply. So, what we're going to talk about is drivers. What are drivers? And application programming interfaces, APIs, what are those? How do they work with each other? So, my background, my accreditation background is in networking. So, I look at problems with reference to models. So let's look at a model. Now, I don't feel like drawing all 7 layers of the OSI model. On my whiteboard here. So we're going to go to TCP IP. Now, a TCP IP model consists of your application layer, transport, we have a network layer, and at the very bottom we have a physical layer, which is comprised of both the data link and the physical layer of the OSI model. Application layer of the TCP IP consists of application, presentation, and session layers. Layers I don't really deal with in networking. But we're going to talk about them here. Like simply, application layer example would be get on a web browser and send off an email. You have node-to-node communication with every layer. I mean, that's what these models are about. They're basically about node-to-node communication. And at the application layer, we have applications communicating with each other, right? At the transport layer, we have segments, UDP, TCP, and that travels down to the network. Then we get to the bottom, which is a physical layer. So why do I find this useful for explaining something like drivers and APIs? Something that is not necessarily something you think about with reference to networking, but this model teaches you where things sit, and that's why these models are useful. Once you know where they sit, you kind of know what they do. And it provides simple ways to explain what might otherwise be complex subjects. And you can't get into the weeds with something until you simplify it. You simplify it first, and then you get into the weeds. This is how I simplify it. I'm not saying it's the be-all and end-all, but this is the way I look at it. So what do drivers do? You have your OS, Windows, Linux, etc. And then you have your graphics card. Your OS speaks OS. Your graphics card speaks graphics card. You need a translation tool. That's your driver. Your driver takes information from the OS via APIs, or from, I guess you could say, from APIs via the OS, and it translates that into the bits and bytes layer. It translates that into something that the hardware can understand. We're talking about voltages. We're talking about resource allocation. All of these types of things that exist at the physical layer. But it has to understand these commands, and it understands them via a translation tool, if you will, called a driver. What do APIs do? Well, let's say you have a software. You know what? Let's say you have a service. You have some sort of service. Let's say you have a service like graphics rendering. It's perfect. And then over here, you have some, I don't know, some other service. And let's make it, let's say you have a service / software, let's say. Now, one service through a given software can be written in one programming language, and another software can be written in another programming language. How do they understand each other? Well, through an application programming interface. They understand each other through a translation tool. The translation tool at this application layer is an API. The translation tool at this physical layer is the driver. Application, transport, networking, physical. Here is your dividing line between application and everything below it. At the application layer, your translation tool is the API. At every layer below that, your translation tool is the driver. Now that is simple, reductive, but it's a way to understand a complex subject. And the reason I think, maybe not the way, but a way that's simple for me to understand it. Think of both APIs and drivers as translation tools for their respective levels of the TCP/IP model. Now, what allows those graphics to be rendered onto your screen when you're playing a game? That is the communication that occurs between driver and API. These tools translate what they need to translate so they can understand each other. And that's what allows you to play your games. A lot of the bugs, now many of the bugs that you'll see as a consequence of graphics driver updates are the result of a bad communication between APIs and drivers. And a lot of the fixes are driver fixes, and a lot of the fixes are API fixes. Kronos will develop something that makes your graphics card work. It might not be Nvidia. So you have to understand these concepts. You don't have to get in the weeds, but you have to understand them simply before you start bitching about drivers. Because one of the things that's kind of unfortunate in the hardware space is people will bitch about things before they understand them. And they'll bitch about a driver before they read the release notes. So we're going to go over the release notes of the recent driver, but not to keep the video too boring, I want to go over something that the recent 576.88 did not address, because they can't address everything. You have to remember, don't see, just because it's Nvidia, don't see everybody over there as some nameless, faceless corporation. No, they're people just like you and me. They've got engineers. They got the same goal, which is to make your shit work, right? And these engineers are working really, really hard. They're good guys, they're good people. They're nerds just like us. And they're doing the best they can. But they will tell you in the release notes, here's what we fix, here's what we know is still out there. So we've got some issues with dual monitors. Since I have the setup here, I'm going to try to replicate those issues, and then we're going to try to solve them. We're going to see what we can do about them in the Nvidia control panel. We're going to see what we can do about them using various cables and various configurations, DisplayPort and HDMI, etc. And so we're going to test things. But I just wanted to first introduce these concepts a little bit in a simple way that ought to be sensible for people. So now that we understand these concepts, let's try to get into the weeds a little bit. Talk about the API and driver interaction and how it might be leading to some of the bugs we're seeing in these drivers. And then we're going to go over 576.88 specifically, and we're going to try to replicate some of the issues that many users are facing, and then we're going to try to fix them.